Yes, welcome again to class. Good morning or good afternoon, whatever time you're watching this video. This is Teacher Okata and I'm taking you through composite functions today. We already looked at rational functions in the previous lesson. We also looked at inverse functions. Now I want to look at composite functions. And we say a composite function is particularly that which consists of two or more functions in one. For instance, if you had a function f of x equal to 4x plus 3, there are two functions in this case because why? We have the case where we are multiplying by 4 and we have addition of 3. So we have two functions in one. That could be termed as composite. But if we have g of x equal to 4x plus 3 as another function, and then f of x equal to x plus 1, these are two functions. One is g of x equal to this, and then f of x equal to this. Then when we write gf, combining them together, gf of x, or you talk of fg of x, these are also termed as composite functions. We will call them composite functions, and you will find them a lot in the past papers. So if the composite function is gf of x, then it means you perform f of x first. F of x is performed first, and then the result of f of x, you perform it in the function of g. That is what it means. But you have to take note, be very careful with this. Composition of functions is not commutative. In other words, you cannot interchange. When you write fg, it is not the same as gf. And we are saying composition of functions is not commutative. When you write gh of x, it is not the same as hg of x. And with the tested results, you will see that this actually is very true. Now we need to look at what exactly composite functions are. What exactly is a composite function? You want to understand composite functions very well. Now look, if f of x is given as 3x plus 2 and g of x is equal to x plus 1, remember, if we want f of 2, it would be equivalent to, in the function of f, we put 2 for x, so you have 3 into 2, then you add the 2. That will give you 6 here, plus 2, which gives you 8. In simple terms, what we have done here, we have substituted for x as 2. That's what we've done in simple terms. That means if you want a composite function f g of x, in simple terms, it means also we are going to get this g of x and substitute it in position of x. So it would be 3 into g of x plus 2. In simple terms, we have substituted for x as g of what? As g of x. But we know very well that g of x is given as x plus what? 1. So we shall have fg of x as 3 into x plus 1 and then plus 2. This will give us 3x. Here you get 3 plus 2, giving you a composite function of 3x plus 5. So that is the fg of x. So this is how we get or derive a composite function from given functions. Yes, now we're looking at an example. Remember, we're looking at composite functions, but in working here, we can also be asked about the inverse function mixed together with the composite function, because we have already looked at the inverse functions. Now look at this one, composite of f g of x, given that f of x is 1 minus 3x and g of x is x squared. So we shall say this f g of x, it means we are putting the g of x into the f function. The f function is 1 minus 3x. Where there is x, we are putting there g of x, which we very well know as 1 minus 3 into what we have as g of x, which is x squared, giving us 1 minus 3x squared as our solution for f g of x. Remember, f g of x is not the same as g f of x. So in your personal time, you can also find g f of x. You can find g f of x, and for our platforms for marking. Then after getting f g of x, we are being asked now to find gf of 2. Now I will cancel my question that I've given you, because we cannot find gf of 2 when we don't have gf of x. So we're going to continue here and first find what I've given to you, but I hope you had paused the video first and then worked out this particular number. So when we are asked gf of x, in this case we're putting f of x into the function of g, which was x squared. So it shall be f of x squared, but f of x is 1 minus 3x, so this is what we're having squared. And when you expand that, taking you back to senior 2, where we look at expansion, 1 minus 3x squared, this is quadratic in nature, we would have 1 minus 6x plus 9x squared. That is how we get in case it is required as an expanded form. But if not, you would still leave it like that. Now we're going to use this gf of x, which is 1 minus 6x plus 9x squared, to be able to get gf of 2. So gf of 2 will now be, remember we are borrowing from this, and we shall substitute wherever you have x, the value 2. So we shall have 1 minus 6 into 2, then plus 9 into 2 squared. And when you work this out, you will get 1 minus 12 plus, this is 4 times this, you get 36. So 37, that is addition of this and that, minus that, you get a final answer of 25. So the value is 25. But remember, you could also work out at this stage, substitute for 2 here. This would be 3 times 2, that is 6. 1 minus 6 is minus 5. And when you square, indeed, you still go back to 25 as gf of 2. Gf of 2. Now that is part B. We're now going to part C. Part C, we shall start working it out from down here. It requires you to have G inverse, because they require you to find FG inverse of 4. We cannot continue before we first get G inverse. We first get G inverse of X. We follow the procedure as we learned in the previous lesson by letting, first let say y equal to the function which is x squared.
And then afterwards we make x the subject. X the subject is root of y. After making x the subject, we substitute for this as G inverse, and G inverse will now be equal to root of x. Where you have the unknown, you also substitute back the x. So that is G inverse of x as root of x. We now require to continue. Remember, we have to get fg inverse of 4. But before getting fg, which is a composite function of 4, we shall first get fg inverse of x. So fg, continuation from this, gives you fg inverse of x, as to means you're getting this g inverse of x and putting it in the function of f. The function of f was 1 minus 3x. So we shall have 1 minus 3 into root of x. Where there's x, we put square root of x. With that now, we can now get fg inverse of 4, which means in fg inverse of x, where there is x, put there 4, and that will give us 1 minus 3 into, this is root of 4, and root of 4 is a plus or minus 2. So we shall have two values for this. First value, we can have some side work. When this is positive, this will be minus 6. So we get a result of negative 5. Whereas when it is negative, this becomes a positive. Negative 2 times negative 3, we get 6, and then plus 1 to give you 7. So the values of fg inverse of 4 are negative 5 and positive 7. That is it as our first example under these composite functions.
No.
So for part C, we have it as f inverse of 4 is equal to negative 5 or positive 7. Negative 5 or positive 7. So we shall have more videos and more examples, of course, to improve on this lesson. But get to the question bank and do more numbers under composite functions. Thank you.